Hi students, today in the class we learned about the bit masking operation. In this video I'm just going to try explaining how this bit masking can be applied to an assembly language instruction. So as you can see on the screen, normally bit masking ANDing operation is used to extract something. So I took an example here. For example, the original bit he is given here is 101. So assume that these are the values, or these are the status of three sensors. There are three sensors. So the sensor 1 is active, sensor 2 is inactive, and the sensor 3 is active. Active in the sense it has a new value to be processed. So now look here, you want to check, there are three sensors. Out of this sensor, you want to check the first sensor. You want to take the value of the first sensor and you want to process that. So before taking the value of the sensor, you need to check the status. So how can you check only the first sensor? The method is you want to only extract the first sensor flag. So if the flag is 1, you can see that there is a new value to be used or processed. If the flag value is 0, it says that there is no new value. So now look here, how can you only extract the first sensor flag from these three sensor bits? Look here, you have to use an AND operation. So you are going to use AND operation to extract only some small subset from a big set. Okay, so now look here, I'm using AND. After that, I use an hash symbol. This hash symbol denotes immediate addressing. Immediate address means after this hash symbol, the value coming here is not an address. It's not an address. Then what's that? It's just a number. So take that value and just load it into accumulator. So I hope it's clear. Now look here. So now the next one is, there is a B here. B denotes that it's a binary number. So if you just see only without B, then it's a decimal number. Then if you see a B, then it's a binary number. And if you see an AND symbol, then you can see that it denotes hexadecimal number. Okay. Now look here, what is meant by this AND hash B100? That means this is the mask bit. This is the mask bit, this is the original bit. Okay, now how can you just extract only the first one? What I did is, in the mask bit, I kept the first bit as 0 and the remaining two bits as I kept the first bit as 1 and the remaining bits as 0. Then what will happen? All the bits where there is 0 in the mask will be avoided, and the bit where in the mask 1 is there, it will be selected. So by doing this, we got the result as what? 100. Look, 100, where the last bit, which was 1 before, it is got avoided, and only we extracted the first bit. So this is how the ANDing operation will happen in bit masking in assembly language instruction. So let's take the worksheet which we did today. So look here, in this example, before going into that, let me just explain the first answer. Look here, it says that there is a greenhouse. In that greenhouse there are multiple sensors. You know that normally in a greenhouse there will be multiple sensors to check the temperature, humidity, and so on. No? So here in the greenhouse, you have to assume that there are 8 sensors. So in 8 sensors, the address 150 indicates that the byte at the address 150 indicates the flag from these sensors, 8 sensors. Flag means it's not the actual value from sensor. It is a status of the sensor. Status, it means that you know that the character of flag is sensor will be keeping on checking the in this case greenhouse. Inside the greenhouse, what is the value of the required what I can say? In this case, we can tell that temperature. So for example, assume that the first sensor is temperature sensor. So it will be always keeping on checking the temperature value. If there is any change in the temperature inside the greenhouse, it will be indicated by 1. So it is not the actual value, temperature level. Okay, it is saying that there is a change in the temperature. How it can be changed, noted. You can see that if you check here, assume that the first sensor is temperature sensor, the second sensor is humidity sensor. So in the temperature sensor, you can see that the value, the flag value is 0. Flag value is 0 means that there is no change in the temperature in the as per the previous check and the present check. So if there is any change happens, these sensors checks the value, atmospheric value in each time interval. So in the last two checking, if there is no change, then it will be 0. In the last check, if there is a change from the previous check, then it will be indicated with the flag 1. So you have to note that these are not the values from the sensor. This is the status of the sensor. So if there is a 1, then you can see that there is a new value to be processed from the sensor. So from where you can get the values? You have to go here. The value from sensor 1 is stored in 201. The value from sensor 2 is stored in 202, and so on. Everything is explained here. You can read this one. Now let me go down. Interpret the current reading for sensor 2. Current reading for sensor 2. So when there is a question like this, you have two areas to note. The first area is the flag value, and the second area is the actual value from the sensor. So what is the flag from sensor 2? Sensor 2 flag is 1. It indicates that there is a new value to be processed. So you can write that new reading from the sensor is available for processing. Okay. Now the second thing is you have to go to the data part. If you go to the data part, this is the actual value received from the sensor. So what is the value? 0, 0, 0, 0, 0, 1, 0, 0. So if you convert this one into decimal, you will get 4. So you can write that one as well. New reading value is 4. Okay. So now let me go to the next question, accumulator part. So we learned that how to extract only the some special areas from a bit or from a byte. So in this case, we know that the accumulator is loaded with data from location 150. So from the location 150, this byte is loaded to the accumulator. Look, LDD 150 means from that 150, we loaded that value into accumulator. Now, write the assembly language instruction to check whether there is a value waiting to be processed for sensor 6. To check whether there is a value waiting to be processed for sensor 6. Only for sensor 6 we have to check. We have to avoid all the other parts. Look here. Actually, by looking at this, we can see that there are values to be processed from sensor 2, sensor 6, and sensor 8. But as per the question, we have to check only sensor 6. So how can we extract only the value from sensor 6? Or only the flag from sensor 6? So we use one AND operation. After AND operation, if you use hash, it says that after the hashtag, the value what we are writing is not an address. Okay, just load this value into the accumulator, or you can use it as a mask. Okay, now after that we use a B symbol. B symbol denotes that it's the following is a binary number, or an AND symbol denotes that the following is a hexadecimal number. If you don't use any symbol like D or AND, it says that if you just simply write that value, then it says that it's a decimal number. Now, if you use like this, look here. This is the mask byte and this is the original byte. So if you just compare this 0, 0, 0 like this, so we are removing all this area, and which one we take? Only the sixth one. Why? Because in the sixth place in the mask, there is 1. Okay, you know that AND is used to extract. So using this mask, we extracted the sixth flag, sixth value. That means the flag from sixth sensor, not the sixth sensor flag. So it is 1. Okay, so then that value will be taken for processing. So this is the answer for this question. I hope you understand. So you only have to write either this or this or this. Okay, so I can write it like this for you. So here, any one of these you can write. Thank you.